All right, so what we're going to do now is maybe look at another shape that you may or may not have seen before, but it's called an ellipse. And what it is going to be pretty much just a circle that has maybe been stretched or contracted a little bit. And it can actually be stretched in either the X or the Y direction. So just kind of a review of the previous section. We have a circle of the equation x squared plus y squared equals 1. That's the same as like x minus 0 squared plus y minus 0 squared equals 1. So the center of that would be at your 0, 0, and the radius 1 squared is 1, so radius 1. So we call it the unit circle. It's kind of at the default position, and it has radius 1. That's where the word unit comes in. So what we're going to look at now is this different equation. So what you can see here is x over 2 squared plus y over 3 squared equals 1. So it's kind of similar to what we have up above there, but obviously a little messier with that division. So I'm going to go to the side a little bit. Let's say we solve for y. So if I do that, I'm going to move the x over 2 squared over. And I have to get rid of that square. So I'll have y over 3, and that's going to be a plus or minus square root. And then all I need to do from there is actually bring that divided by 3 up. So I'll multiply both sides by 3. And I'll put it right there beside the root so it looks nicer. And so what we get is this horrible messy equation here. And maybe this doesn't look like anything to you, but if we go back and compare it to what this unit circle looks like, well, this is y squared is 1 minus x squared. Y is plus or minus root 1 minus x squared. And so if you have a look at this, hopefully you can maybe see that what we actually have here are transformations, right? You remember your A. I'll write the general formula out. Y equals A, f of B, x minus h plus k. And so in these transformations, all that I've got right now is just stuff on x and stuff on the outside, multipliers. So what we have here is this b, which is right on the x. And so here's the x here. And then now it's inside the square down here. So this over 2 is actually our b. Now that you probably could have figured from just looking at this. It's a little abstract because this whole thing does look a bit different than before. But you might have seen like x becomes x over 2. And so if you remember what that means, that is a horizontal stretch by 2. So yeah, so that's going to give us this horizontal stretch by 2. But now what we're going to see is the y. So we have this thing that's on the outside of the whole function, and that's this number here, the 3, and it's coming from that 3 there underneath the y over 3 squared. So that is going to be a vertical stretch by 3. And so what you're actually seeing is on the y, because it's inside of that bracket the same way that x is inside, they're sort of like they're both sort of inside the function now. And so when things are on the inside, we do the opposites. And so that division in both cases creates a stretch. So yeah, so what we have here, our result is going to be the unit circle. So vertically stretched by 3. And horizontally stretched by 2. And so if we take that picture, right, so what I've done is I've drawn the unit circle. It's a little smaller because my scale is a little bit smaller, but the dotted blue lines are the original function. And then what we could do is have a look at the transformations. And so that vertical stretch is going to make that height of 1 go up to 3, and -1 go down to -3. So that's that stretch. The horizontal stretch by 2 is going to double the width. All right, so it's not shifts, it's going to be pulling it apart. And then what we would do is connect all the dots. And what you get, it's not quite a circle because it's obviously taller than it is wide. So we get this kind of football-y shape or oval shape, or what we would call mathematically an ellipse. So we're not going to do this much work to graph all of these. What we're going to do is just kind of summarize what we did here. Okay, so to summarize, to kind of include the couple of concepts. Oh, something got erased that I didn't want there. Let me draw that. If we have x minus a squared plus y minus b squared equals 1, so this was from the circle stuff, that's going to be your circle with radius 1 still, but centered at a and b. And now, if we have this division in the expression, so if I have x minus a squared over like some number, so I'm writing rx, so it's like the radius in the x direction, so some number squared, plus y minus b squared over ry squared equals 1. So this is going to be the equation of an ellipse. So it's centered at a and b, just like the circle, but then it's got these stretches. So I did write the r's kind of outside of the square, but I think you can maybe see that you could rewrite this equation here as just x squared over 2 squared plus y squared over 3 squared equals 1. So kind of the same thing. So that would give us a horizontal stretch by the rx number and a vertical stretch by the ry number. And yeah, so you can hopefully see that in this equation that we just did. The rx would be 2 because it's 2 squared, and the ry, the y radius, would be 3 because it's 3 squared. And then the a and b in that case would both be 0. All right, we'll do a couple examples here. So for this first one, we're going to sketch x minus 3 squared over 9 plus y plus 1 squared over 4 equals 1. So this one's really nicely written in the format that we're given there. So if we have a look at all of our pieces, this is our x minus a. So a is 3. And this is our y minus b. So b is -1, so that we get the same thing there. And then what I'll have on the bottom, this is my rx squared. And so that tells me my, let's just call it the horizontal radius is 3. So that's just that the distance from the middle outwards in a horizontal direction. And then this would be my vertical radius. Would be 2. And again, you can say plus minus 2 if you like. It doesn't matter because we go both up and down. And so this should be enough information to sketch everything. Okay, so I've got my axis ready. So we're going to use the A and B to tell us where the center is. And so it's at 3 and -1. And if I'm going to do the horizontal radius of 3, so what I'll do is go left and right by 3. And then similarly, the vertical radius, so I'll go up and down by 2. And so those are all of my points. And I guess what I'll do is just pick a new color and color this in. So it's just going to be sort of the roundish shape that hits those 4 points, not the middle. The middle is not part of the graph. And so it should, yeah, look like that because those two, the stretches are different numbers. All right, so we'll just do one more. All right, yeah, so just one more. What I'll do is actually show you maybe 2 different ways to sketch this last one because using the same method as before may not be the most practical for you because it's a little bit of extra work. But we'll start with the previous method. And so what I'm going to do is put it into this notation above. And so in order to do that, what we need is like equals 1 on the right. And so if I'm going to do that, what I've got to do is divide everything by 400. And so I'll have 16x squared over 400. These are really two terms here. 25y plus 2 squared over 400. And then on the right side, we have the equals 1 that we want. And then what we can do now is clean up these numbers a little bit. 16 over 400, well, that's not going to quite work, but 400 over 16 is 25. And then on the right side, 400 over 25 is 16. So I can put that on the bottom. All right, so now it's in the correct notation. I'm going to use a red check mark to be consistent with the notes there. And so now what we do is identify our center. So there's no shift on the x, so that's 0. And then the y would shift left by 2. And then I'm going to get my, let's say, height. So I'll use my width first. So the rx squared is 25. So my rx is 5. And maybe my ry squared is 16. So ry is 4. And that should be all we need. All right, I got my axis, so I am going to start drawing. And I guess in orange, I'll do my center at 0 and -2. And then I'm going to go left and right by 5. And then up and down by 4 from the center. Yeah, looks right. And then just connect those dots in a round-ish shape. Well, it doesn't look like my scale is all that good, so I'm going to fudge it a little bit. That looks all right. Yeah, so that would be our ellipse there. So I think what I'm going to do is show you a different method of doing that. So I'm just going to move the graph there so we still have it for reference. Oh, I did not get all of it. Oh, I know why. Okay, hold on. And I'll show you a different method that's kind of just a different logic you can use there. All right, so the second method, oh, it's really small. So the second method, what we'll do is basically just find the outside, like those mins and maxes. So find the left and rightmost point and find the topmost and bottommost points. So yeah, so if you have a look at the graph, which we already know what it looks like right now, but if you look at where the left and the rightmost points are, notice that they do occur when y is at its center y. It's the same y as the center value. And the y at the center is when this thing here equals 0. So that's sort of the idea. What we'll do to find the left and rightmost x's is make the y chunk 0. So that is going to happen when y plus 2, or I can put the 25 in if I like, but when y plus 2 squared equals 0, which is going to be at y equals -2. And when we have that, when this thing equals 0, what we get is 16x squared equals 400. And then what we can do is just solve this for the two x's. So x squared is 25. X is plus or minus 5, right? The positive and the negative roots there. So when we put this all together, we get 5 and -2, and -5 and -2. Those are exactly those 2 points right here. So we can find those 2 points. And then step 2, we're going to make the x piece 0. And so that's that 16x squared. Which tells us x must be 0. That's the only way to solve that. And then if we have that, then again, what we're left with in the equation is 0 plus 25y plus 2 squared equals 400. And so we should be able to solve for y from this. So I divide both sides by 25 to get y plus 2 squared is 16. We'll take the roots. So it'll be plus or minus 4. And so y is negative 2 plus or minus 4, which would be positive 2 and negative 6. And so that would be these 2 points on the graph. So I'm not going to redraw the graph because it is right there. But this is just a slightly different method, which I did write it all out, but you might be able to do a lot of these steps kind of in your head. So rather than doing the whole repackaging thing, which you really do need to write out, you might be able to get your answers a little faster using this method. So kind of up to you, I guess, but this is a suggestion. So yeah, that's basically it for equations of ellipses. You might be given something that you need to complete the square on, and if that's the case, I did do an example of that in the circle video. Yeah, this is graphing it, so we'll just, let's do another video for finding the equation.